Awesome. All right, so yeah, I was going to start by complaining about having to wake up early, but apparently not everybody shares the same concern. So thanks again for the invitation. In many, like to a large extent, putting together this talk allowed me to think about some of the work that I'm doing in a different way through the prism of interactive learning. And as a general statement of what I would like to talk about is basically two big ideas. The first idea is that relying on neuro-symbolic representation is a very good opportunity, in my mind, for supporting interactions with humans and learning language through interactions with humans. And the idea here is that the symbolic representation is an easy way to bridge between human level, the sort of human understanding, because these symbols are human readable, and compile them into a machine learning model down the line. The second big idea that I'm very interested in exploring in this talk is a new domain, which I think presents a good opportunity for interactive learning and has so far been somewhat neglected, which is computational social science, opinion, and argumentation mining, where we have to deal with very, very complex concepts that are, on the one hand, very well defined and understood by people in the social science community, such as, concepts of morality, framing, ideology, and so on. They're very accessible to humans, and they provide a very nice level of abstractions when we try to communicate these to computers. However, acquiring these concepts from a machine learning perspective is challenging. And therefore, communicating this knowledge through humans is, in my mind, again, a nice opportunity. All right, so as I've warned ahead of time, I've sort of put these ideas together quite recently. So feel free to stop me at any point with questions or other comments. I'll try to open the chat so I could also see that, but also feel free to just, join in at any point and unmute yourselves. All right, so from a very, very high level, we can think about machine learning as communicating knowledge from humans to machines. And right now, this is done in a very inefficient way. Like we rely on labeled examples as the mean of this knowledge communications. This is not exactly natural for humans to communicate in this way. We don't learn from 10,000 examples. We usually learn from an explanation and maybe a handful of examples. Having just conveyed all this criticism, it has been extremely successful as a paradigm. However, not without its drawbacks. Annotation can be costly, especially in complex domains where specialized knowledge is needed. The end-to-end approach of annotating a bunch of data and then throwing whatever is the state-of-the-art transformer on top of it results in a monolithic model that is very hard to reuse and it's hard to share information across related tasks. And since we're dealing with language, especially the language of opinions and other such related domains, it's going to be very, very sensitive to changes in the input, and we're going to suffer from concept drift as new topics emerge and the public discourse changes. So an alternative to that has been, again, very, very successful is to learn from interactions by observing behavior. So these are slides that I've made in grad school, and so 2011. So this is definitely not a new idea. And we can think about this like this is a semantic parsing task where a human communicates a Siri-like command, I'd like my coffee with no sugar and a bit of milk. This gets converted into some intermediate representation, slot filling, if you will. Rather than annotating this intermediate representation, we just rely on, well, did we get the coffee that we asked for in the way we specified? So it's a very natural form of supervision. It's easy. It's often very cheap to obtain. It comes up naturally by observing interactions, and it can be applied very broadly in many domains. So click-through data behavioral data where we observe people's reactions. We can define expected behavior or answers if the underlying representation of that is learned by the model is correct. In more advanced scenario, we can try to infer from the user's emotional tone whether they're happy or not about the response, and so on. And this has been extremely successful, and it is used by essentially all social media companies to optimize the content they provide for us. So it's been very successful, and it's hard to argue with that, but still, as an account for knowledge communication, it's not great. It basically makes the previous approach of the costly step of annotating examples cheaper, but it doesn't still communicate knowledge in an easy way. The bandwidth of interaction could be much, much greater. And in some sense, humans are great reasoning machines, a lot more than they're a learning machine. And we don't learn by example, we learn by matching new information to previously acquired concepts. This is just my attempt to find reasons to put pictures of my son in the slides. So this is something that he told me a year ago when he was just turning 3. My teacher said that lightning is dangerous, knives are dangerous too, they are sharp, therefore lightning is sharp, which I thought is pretty impressive for a 3-year-old. The idea behind it is that we can characterize the learning problem using an intermediate concept, and these concepts can be shared across many different learning problems, right? So we break this sort of monolithic approach to learning. We can think about learning as a form of communication in an easier way now. These intermediate concepts can be viewed as a form of a shared vocabulary between humans and machines, and we're trying to acquire this vocabulary in a form of grounding these concepts in raw data and combining them together into more complex decisions, right? And interaction can be seen as the human teacher debugging the learner internal representation of how these concepts are formed. So as a working definition of what I mean by learning from interaction, we can say something about communicating the human rationale about a task via intermediate judgments, explanations, maybe sub-goals or intermediate steps that are needed in order to get a better result from the learning system. So wonderful. How can this be done? At a very high level, my general claim is that rather than doing it directly over natural language commands, we can use symbolic representations that are human readable to define these concepts and ground them in raw data. So I think about it as this form of compilation process where humans can specify a set of concepts and connect them into a rule. For example, this defines the concept of a suspicious truck in, let's say, in an image where we say that there is an image and, there is a vehicle and the vehicle is working, it's in working condition and it has camouflage color, and this, should raise some flag if it is identified by the system. This can be directly communicated by a human, then our task is to convert this into something that machines can actually apply on raw data into, currently a neural representation. So this, we can think about interaction here as communicating knowledge through capturing dependencies and learning as debugging the concept through interactions. This is not by no means trivial. So there is a general question of course, where do the relevant concepts come from? So if I'm suggesting this interaction through a symbolic language, I need to justify the concepts that I'm using. And then we also have a bunch of technical questions. For example, how do you ground concepts in raw data? So when I say something like, working condition, how do I identify that in text or video and so on? And then finally, how can we compile that into a working classifier? Like, how do we compile this into a decision-making classifier? None of these are easy problems. In some sense, the focus of this talk is about the first question, where do relevant concepts come from? And I'll try to discuss several symbolic explanations that we found very useful when working with computational social science problems and analyzing political discourse on social media. I'll also discuss a declarative framework for neuro-symbolic computing that answers the second and third questions, which, hopefully more people will use it. We released it in NACL this year, so hopefully we can start building a user base around it. Another thing that we could try to do is to rely on the same principles, not during learning, but rather after learning. And we call this advice, where rather than training from scratch using this kind of explanation, we want to think about a protocol for observing the learned system and then giving it advice, correcting through these kind of natural language or symbolic explanation, the decisions that it makes. I'm mostly putting this as a plug for my student Nikhil's talk that will be a little bit later on, where he applies this advice giving protocol to fake news detection later in this workshop. So go see it. All right. So now I want to talk about why does political discourse analysis and opinion understanding is a very natural fit for interactive learning. First of all, we have a lot of text and a lot of context that comes with it. So there is naturally a lot of, as you might have noticed by now, a lot of people with opinions on the internet. And this is coupled with their behavior on social network, a lot of click-through data, a lot of social information about whom they follow, who they choose to engage with, and so on. So there are many types of indirect interactive protocols that can be exploited here. There's also the point that it is extremely dynamic. And if we were to take the traditional monolithic supervised learning approach, this is definitely a moving target. It's really hard to keep up. And finally, and perhaps most interesting from my perspective, is that the explanations that we need to provide here rely on really interesting abstract concepts. So these have to do with how do you define ideology, interests, the type of arguments, moral principles, and many more. So characterizing opinions and explaining them relies on concepts that are highly challenging for NLP. So to make things a little bit more concrete, so you can see if you can answer that. If you talk about healthcare as a human right, then, so this is a human level rationale, probably you voted in favor of Obamacare, right? So when looking at political discourse, let's say by members of the US House of Representatives, the way they discuss healthcare, if I can characterize the arguments that they make as, well, it's related to human rights, I have a pretty strong signal that they would be in favor of the Affordable Health Care Act, Obamacare, or universal access to healthcare. I can write this down using my symbolic language in a way that aligns with the textual representations quite well. And in general, throughout this talk, sometimes I'll just do that because it's easier. We have a tweet. We have the author of the tweet. We identify that the frame used to characterize the topic is fairness, and that has to do with framing theory. The topic is healthcare, and from that, humans tells us that we should prime our decision. We should be primed towards deciding that this author voted in favor of Obamacare. This doesn't necessarily is not only limited to linguistic context. In many cases, there is real-world context, such as social context, that is often needed in order to help disambiguate the text or extract its meaning. And the explanations can rely on that too. As a motivating example, think about, this movie is sick. The word sick here is, of course, ambiguous. It could, depending on your pronunciation and your age, it could be sick or sick, which is, the positive sentiment version of that word. In text, of course, we do not have this intonation. And while I could say about some things that if I say this person is sick, so I got him some chicken soup, any kind of transformer would be able to recognize the right sense of the word. But if I were to say something like this movie is sick, both interpretations are valid. And really, I need to say something about the identity of the speaker and their preferences in order to capture the what does sick mean in this context? Is it good or bad? So in our context, based on the same intuition, we can also think about explanations that take into account the social context as well. For example, if I can say something about the author political preferences, I can say something about what kind of opinions, texts that they write are likely to support. So if someone is a Trump supporter, then the tweet they would likely author would oppose impeachment. Similarly, I can also come up with more complex explanations to characterize social behavior. So if the author follows One American Network, a right-wing news outlet, then they're also likely to support Trump. And we can chain these rules together. We also have other reasons for looking at this domain from a societal perspective. And this has been said many times, so I'll just say it very, very quickly. There is an information pandemic that's going on right now in the world because of the rise of social media as the main supplier of news, specifically in the US and more broadly everywhere. There is definitely a need to contextualize information, verify it, and provide users with the full picture. So there's also societal reasons to work on this. In many cases, the kind of explanation that we can provide can help give a fuller picture. It can help make sure that all points of view are represented, or at least alert when they're not. And in general, it's maybe a first step or maybe a step in the right direction. The underlying issue that we have is how to explain information. And the way that I think about it is as identifying relationships between opinions and different symbolic indicators and potentially other opinions as well. So if I have several claims, I can connect them to stances that people take and different ideas and ideologies that these people would hold. I can identify the relationships between pieces of text. I can come up with symbolic explanations and characterize these opinions by how they frame the issue, what kind of underlying perspective, more general perspective, do they support, the type of ideology that is conveyed to them, and so on. And this is one of the reasons why I think it's very exciting. So when we think about these kinds of symbolic dependencies, we have to come up with a language for expressing them. So this could be through defining these explanation entities, such as, we have a language of what are the possible frames that people use when describing their opinion, and being able to identify it provide us with some indication about the types of argument that they would make. We can also think about typed relationships. So this is not simple similarity, similar or not. We can say that, well, two texts are about the same topic, but they disagree along some dimensions, such as ideology, or they disagree on their stance. When trying to analyze text based on this perspective, we move away from classification to a form of inference where we have to come up with an explanation that is consistent with multiple explanation indicators. We can think about these indicators as latent variables, which can be learned through human interactions. And then the final decision process is done through the rules or the higher level concept that humans provide us with. So from a machine learning perspective, we can think about this as inference over graphical models, right? So we have latent variables here, and these latent variables support, say, stance decision. So let's say that y is our observed variable, which is the kind of stance a given tweet expresses. So we have two of those. And the underlying explanations, which are indicated here as age variables, could be things like what type of frame, what kind of ideology is associated with that, and so on. Okay, so we defined a declarative language for defining such dependencies, where we have symbolic representations of these dependencies expressed through first order logic. So we have typed relationships defined over entities, and these entities can correspond to text or opinions or frames and so on. In our neuro-symbolic representation, these are in turn all embedded. So we have a relation embedding, and which builds on an entity embedding, and all of these are combined together to form the final decision rule used by the machine. So this is the compilation process. For the interest of time, I'll skip the technical details. We can also do, we can also use similar ideas when we are characterizing the social context. For example, we can identify what kind of opinion a person holds, and then assume based on the principle of homophily that their social groups are likely to share the same opinions, and prime our model to associate similar opinions with them. All right, so in short, we introduced DRaiL, which is a declarative framework for deep relational learning. Rules provide context and are compiled into a graphical models, and then neural architecture are used to score them. So we have this sort of DRaiL program that. I'm sorry, is there a question? Okay. So each rule defines a factor template in a factor graph, and it captures dependencies between decisions, and we chain all of these rules together into a neural factor graph, right? So it looks something like that, where each entity has its own encoder. These entity representations are reused across all the relations that they participate in, and then over the the embedding of the relation instances, we define decision rules that are then used for inference. Humans, when they define their explanations, work at this high level of expressing dependencies, the top layer, expressing dependencies symbolically, and then everything else, the embedding, happens under the hood without human intervention, based on data. I'll skip, because I'm kind of short on time, I'll skip some of the technical points, and I'll jump right into constructing symbolic explanations. Always running out of time. All right, so our main point here is to come up with an automated way to decode political messaging, specifically on social media, where the text is very highly ungrammatical, it's highly contextualized, and in general, kind of hard to work with. So we would like to understand both the stances that people make, how they are likely to correlate with decisions and behavior they would have later on in the real world, and to try to understand the reasoning behind these opinions and stances that they have. So here are a couple of examples. This is about the issue of Obamacare. 6 years later, healthcare costs have skyrocketed and millions lost access to their doctors. Repeal Obamacare. Clearly, the stance here can be easily identified, not a fan. A more interesting question here is, well, how should we abstract the tweet such that we can capture the argument behind not supporting Obamacare? So we can replace or we can think about it as a paraphrase problem, where we're saying Obama should be repealed since it's too expensive, as healthcare is framed as an economic issue. And this is an explanation of why this person doesn't support it. So this is a form of explanation or symbolic explanation, the type of frame. And we rely on work that has been done by Amber Boydston, Philip Resnick, Nora Smith, and many others of defining these kinds of frames. Here's a more complicated issue. These are two tweets that are unfortunately written after a mass shooting event in the US. The stance here is really hard. If you think about stance as regulating access to firearms, it is really hard to detect. It doesn't express it directly. So both tweets express the heartache and the pain sharing the heartache and pain by the victims and their families. However, one of those tweets have a very strong, the author of one of those tweets has a very strong anti-gun regulation position, and the other one has a very strong pro-gun regulation position. Trying to identify it can be quite challenging, and if anybody wants to guess, I'm happy to pause for a few seconds. If you look at the way the issue is, the way this horror or the sort of the sadness around the mass shooting is expressed, we see that there are differences. The first one emphasizes notions of unity and togetherness. There's a lot of us language. We stand united in our shock, our prayers. The other one expresses horror, horrific shooting, unspeakable horror. It's very visceral. And if we think about that as the right indicator for detecting the underlying stances, then it is actually distinctively different. One form of explanation that we can have here to support these is to think about the underlying moral foundation. This is a theory that was developed in social psychology, moral foundation theory, and has been used to explain just about anything from political perspective to vaccine resistance to artistic preferences. It claims that human morality is centered around 5. Later version of the theory has 6 main foundations, such as caring for others or opposing harm to others, where the care is somehow justified. Based on the principles of fairness or avoiding cheating, loyalty to a group such as a family, a country, and so on, the need to follow justified authority, and a sense of purity, usually associated with a feeling of something sacred, holy, such as religious beliefs. In the previous example that we just saw, we looked at the difference between a sense of degradation. There is a physical, visceral sense that shooting is bad, as opposed to a sense of loyalty, where we're talking about we should come together at this difficult time. In general, loyalty is more highly correlated with the pro-gun perspective and the vice versa. All right, so this is a nice way to capture that. We've done a lot of work at trying to come up with these kinds of explanations, both for framing and for moral foundation. We've sort of decomposed these concepts into more nuanced concepts to better account for differences in opinions, stances, and behaviors. Again, I'll have to skip some of the technical parts just because I'm running out of time, but here's a discussion around Obamacare, or the Affordable Health Care Act, based on members' frames appearing in tweets by the U.S. representative. Silence their microphones, please. Thank you. So the healthcare debate, and we could see that there are a lot of similarities in how they frame Democrats who supported the Affordable Health Care Act. Also talked about the affordable healthcare as fairness and equality, which is not shared by Republicans. But overall, there is a lot of overlap. Everybody talks about it as an economic issue, as a quality of life issue, and so on. By the way, Republicans that voted with Democrats, there were a few, aisle crossing ones, also talked about affordable healthcare, about the Affordable Health Care Act as an issue of fairness, which is kind of cool. However, it does sort of like raise the question, well, if they both talk about it as an economic issue, are they actually making the same point? And clearly they're not, which suggests that our explanations should be more nuanced. One of the things that we have done is to look at sub-frames, which is creating a hierarchical language of topic, the specific way in which this topic is framed, for example, as an economic issue, And then subframes which break down in a topic-specific way the economic frame into specific points that better correlate with the two sides. Right, so this is an example of discussing the immigration issue on the left and on the right as an economic issue while making completely different points. I won't go into sort of the broader discussion here, but we can see that this sort of subframe approach is a much better explanation. So on the left, we see the original framing decision, which are more abstract, and anything that's on the diagonal means that, or distance from the diagonal means that it's capturing how one-sided this argument is, or the usage of that frame is. For example, the economic issue is used in an equal way by both sides, so it's not a good explanation for stance. When we break the economic issue into finer grained frames, for example, talking about economic in terms of economic development as opposed to tax base, then we start seeing the differences between the two sides. Similarly, when it comes to using morality as a form of explanation, again, moral foundation theory was used for just about anything, and it has been shown over and over again that liberals emphasize fairness, while conservatives emphasize loyalty and authority. But everybody cares, meaning that both sides use the care moral foundation. And this is very natural, right? We all believe that our children should be protected, for example, to, the cliche. But not surprisingly, we don't care about the same things. So if we say, if we think about the underlying moral principle, both liberals and conservatives believe that people who deserve care and protection should be protected. They just disagree on who these people are. So, and this is an example of that where in the context of the healthcare debate, the Obamacare, that legislation is perceived as either providing care or as harming. But in both cases, the moral foundation used here is care harm. So we developed a frame structure to capture the association between the moral foundation used and the different entities that fill in roles in these frames. So if it's care, then who is the entity that deserves the care or is currently suffering from harm? Who is the entity who should provide the care? Who is the entity who's doing the harming? And so on. So for example, if you're thinking about it as providing an explanation, so if the target of care is illegal immigrants, meaning that we should care for the well-being of illegal immigrants, then the author is more likely to be, well, everybody who knows anything about, let's say, US politics would say liberal or progressive. If the causer of harm is illegal immigrants, the author is a lot more likely to be conservative. So if we're still talking about the care harm moral foundation, but the illegal immigrant are perceived as causing harm rather than deserving care. We define these kind of moral foundations, the moral foundation frames, where for every one of these moral foundations, we define specific roles that are filled by whatever the author of the text thinks is the deserving party. We define the DRaiL model. Again, I won't go into it in too much detail, but essentially we have the basic classifiers for identifying the moral foundation and the specific roles. And then we connect it with things such as, the social context of the debate. For example, we want to see how different topics are discussed across different ideologies. So this rule, the rule number 3, captures what is the preferred moral foundation on a given topic by a given ideology. We also include some preference for consistency. So regardless of the moral foundation, moral role used, there are some entities that will always be discussed positively and those that will always be discussed negatively by different sides. So again, we can capture that as part of our explanation, like humans can provide these explanations. In general, like these are a lot of numbers, but the take-home message here is that while relying on BERT as our classifier and using the same kind of pre-training tricks and so on, the difference between using these explanations to help sort of provide scaffolding for the learning process compared to just BERT applied directly is quite significant. So it allows us to move from 52 to 59 and from 63 to 72 for the roles and the moral foundations respectively. So it does help. Finally, we can think about morality frame as a kind of explanations. Like we looked at an aggregated analysis of all congressional tweets on different topics, such as the January 6th Capitol insurrection, the abortion debate, and so on. And we can think about these emerging explanations as if the text describes entity X as having role Y, then it reflects a right-winged or left-winged perspective. And the kind of explanation that we saw is that, for example, in the left, in the context of the abortion debate, our model identified that women are often the target of fairness or cheating, meaning that they are deserving of a fair treatment or they're suffering from unfair treatment right now. While on the right, women are perceived as deserving protection. Let's say Planned Parenthood, which is a highly controversial issue in the US, is perceived in the left as loyal to women or part of the same in-group as the authors, and on the right as an entity that's cheating and being unfair. It is very likely that in that context, the entity that is the victim of cheating would be different than the one on the left. So this provides us with a very interesting mechanism because it captures the expectations which can be easily written down as symbolic rules. In this case, we extracted those from data, but none of this is actually surprising. If we were to write this as rules that form expectations for the learning system, so we would write, if the target of fairness is, let's say, Planned Parenthood, it's more likely to be a right-winged tweet. This provides with a very strong, let's call it curriculum or a lesson plan for identifying moral perspectives in text. It still leaves the question of how do you ground these concepts as open, and the 60% solution is to frame these as latent variables or provide some initial model to start to learn from them. And one of the things that we're working on right now is an interactive concept learning approach where grounding is also part of the interactive learning loop, where we allow the teacher to characterize relevant concepts on the fly by providing some initial grounding model. Students can provide feedback about how they grounded in raw text, and teachers can adapt the definition or provide more complex explanation that rely on previously learned concepts that help refine it and improve it. And we can learn increasingly complicated concepts in this way. We are going to give an HK tutorial on neuro-symbolic methods, where we'll have a Jupyter interactive demo for this framework over data that's related to the January 6th Capitol insurrection, where we have to characterize concepts such as morality on the fly and help that to identify who voted for impeachment, right? So that's kind of I think a cool scenario. All right, I am out of time. So just to summarize, one of the main things that I wanted to pitch here is that the interactions between human teachers and learning system can be done using a neuro-symbolic approach. This relies on breaking down the task into intermediate concept that teachers can explain. We have a language called DRaiL, declarative language for supporting such symbolic interactions and converting them into a neural models that's publicly available. Our focus is on applications of argumentation mining and computational social science, which I think is a very good domain for interactive learning. And it's in some sense relies on concepts that are very clear to humans and yet very complex for machines, which I think is a very promising domain for these kinds of interactions. Finally, all of this work is essentially done by my wonderful students, which I'm very grateful for having. So I'm looking for every opportunity to say thank you to them. And with that, I'll stop. And if there are any questions, I'm happy to take them. Thanks. That's a great question. In some sense, that's the most basic thing that we have to account for is where do these explanations come from? One of the reasons why I think computational social science is a great domain for this is because there are people who do this work for us in a way. There are a lot of people in social science that look for these kinds of explanations from psychology, philosophy, and so on. Specifically, the one that I've used are from political science and social psychology. And one of the things that we do is we try to, using data, break down some of these concepts that were more theoretical in essence into something that's more data-driven. So for example, morality, providing a frame structure for morality allows us to better account for how this matches stances or other things that you want to predict. I think that what would be a wonderful thing, and I'm really excited about this, is to put experts in a room with this kind of symbolic interface, have a 10-minute tutorial of what is first order logic, and now start writing down explanations and train the model, take half an hour, like 100 tweets, half an hour, and build a complex classifier that for morality, right? Because these people do understand these concepts and they're able to capture very, very fine-grained, nuanced insights that would have taken thousands of examples otherwise. That's a good question. I haven't thought about that. I don't know about explanations for the explanations, but we do need to provide justification for the explanation, which I think it's sort of along the same lines, at least to the extent that we should be able to show that our explanations are consistent with the data. They're internally consistent as well, so they don't contradict each other. And depending on the audience or user, what kind of explanations we would generate is a great question. I haven't thought about it, but it is true. Like for different applications, different explanations would be needed. Yeah, that's a good question. I think that is definitely something to think about. So we've done it sort of anecdotally in the sense that we've run the model and then validated that they do provide explanations, but we haven't sort of reversed the direction by writing down, well, if you believe that, I don't know, immigrants deserve care, then you're more likely to be a liberal, right? So we haven't done that in a sort of extensive way. Like one of the things that like I'm hoping to finish doing over the summer, we're working on this now as a project. So hopefully, we'll have some results for the next iterations of conferences. But it's definitely something we work on now. Thank you. That's a great question. So about the first half, which is why DRaiL and not other semantic representations. So AMR and all other many sort of predicate argument-based languages are semantic representations for the text. We still need to, we don't have any abstractions really over that, right? It's capturing some information such as, what is the entity in the subject position and so on, and, to more information to various degree, depending on the formalism. But what we want to do is come up with explanations that are much more abstract and don't directly appear in the text. So in our case, like the example that I gave here is, I want to identify things such as morality roles in the text and use those as an explanation. These might not correspond to the subject-object position that a lot of these languages rely on, right? So it's just working at a different level of abstraction, and it uses a different vocabulary, right? Because the symbols that I care about in the explanation for my domain might not correlate or correspond to the ones that I would get from AMR. About the second question of how easy would it be to come up with different explanations for different applications, for example, a different frame structure. So I'm tempted to say very easy because I'm, have an interest to say it, but in some sense, the definition using DRaiL is very easy. You just define a new frame structure and then express the dependencies using first order logic. In my experience, the hard part is not that. The hard part is grounding. A lot of the time, these concepts or the explanation rely on concepts that are very, very hard to characterize in the text because humans think about things in a very abstract sense, right? So if you think about it, something like purity or a sense of sanctity can be applied to religious concept. It could be relied to healthcare activity and well-being activities like yoga. People feel, clean and in some spiritual ways, those activities. And these are really hard to characterize. So I think the true difficulty lies in the grounding aspect. In some sense, like we have a symbolic language, and events and grouping of events, like we could say events, we can have a grouping of events as, events related to giving activities or to violent activities or to sharing activities and so on. These are symbolic vocabularies that can be used together, right? So I agree with you that a lot of the grounding problem can be alleviated by having more intermediate concepts, right, that are derived from an event representation, right? And you can also build expectations about certain entities would fill certain roles